Look at logarithmic function. So here is what we're used to seeing for an exponential function. We have our y value, if we're going to graph it, is equal to some base, which is a to the power of x. Okay, and the inverse of that is a logarithmic function where the base is the subscript of the log, and the x is no longer the exponent, but is the value that the log is to. Okay, so logarithmic function is essentially an equation. It's going to be putting it into an equation. Okay, now if we're going to look at just converting values, these two are technically equivalent. Okay, so where y is equal to log subscript a x, x is equal to a to the power of y. Okay, so the first thing I think we're going to do is maybe just try converting two versions of this. So we have log subscript 2, 8 is equal to the value of 3. Let's try to write this as an exponent. Okay, the first thing we'll do is we'll figure out what variable each of these stand for. So our a value in our log is going to be our number 2. Our x value is going to be the number 8. And the y value is going to be the number 3. Okay, so according to what we've written here, our x value is what everything will be equal to. So our x value is 8 is equal to. Our a value becomes the base. So we have base 2. And that y value, which is the number 3, is going to be the power to the power of 3. So does this ring true? Is 2 to the power of 3 8? Yes, that's right. So these are equivalent. These two on the right here are essentially equivalent functions. So let's do the same thing with an exponent or an exponential function instead. We're going to turn this into a logarithmic function. So if I were to turn this into a log, I have log. Does anyone know what the subscript is going to be for the log? 4, that's right. We're going to have 4 subscript. Okay. And what is our x value going to be here? 16. Okay, and what is it all equal to? 2. Did I write the colors wrong there? 2. Okay, great. It's all equal to 2. So another way we can kind of think of this idea, okay, is a bit of a shortcut for converting logs, is I could also write it like this, and sometimes this is easy to see. Since this is subscript 4, I'm going to write my x value as a base 4. Okay, so how can I write 16 as a base 4 exponent? What can I replace 16 with? What base 4 is equal to 16? So if I have 4 to the power of something is equal to 16, 4 squared, yeah, 4 squared. So we can also write it like this, 4, and then I'm going to write this little 2 in black here, is equal to 2. Okay, now I wrote the equal to 2. Sometimes logs are written this way so that we can easily see what they're equal to. If the subscript is 4 and the base is 4, or in other words, if the subscript and the base in the log are the same, it's going to be equal to whatever the exponent is. Okay? So that's just kind of writing logs from exponential functions to logarithmic. You guys are going to try it a little. Hopefully it'll make a little more sense as you pass through it. We'll talk about how these two are inverse of each other. Okay, so we're going to switch to the other page here. So I have y is equal to log subscript a x, okay, and now technically this is the function it's equal to. Okay, you'll notice as I take red away, it turns into the green function. So this is the one that it's equal to. But when we write functions, we usually don't write them as as equal to x. This would be considered the inverse. So this is how we would normally write an exponential function. We have y is equal to some base, which is our a value, okay, to the power of x. And the inverse of that is the logarithmic function. You'll notice that the purple function and the green function are inverse of each other. Essentially, they're flipped on a linear equation that would be considered y equals x. Okay, so as we change the base and as it gets larger, now let's kind of focus on our purple one here because this is probably what we're more familiar with. This would be 5 point, and maybe let's use a whole number. This would be essentially y is equal 5 to the power of x. So an exponential function, y is equal to 5 to the power of x. So we know that would be 0, 1. So if we're to the power of 0, it's equal to 1. What would 5 to the power of 1 be? It would be 5. So what that means is x equals 1 at this point here. we know we're equal to our 5 here, okay? And that's going to be important. What would the inverse of that be in our other function? What would the inverse of this point be in our logarithmic function? What's that? 5, 1. So if I write a function saying y equals 1 here, we get our 5, 1. So these two are inverted points. Okay? So all this is really trying to show you, since it's the first time you've seen it, is we're just trying to explain that these are inverse of each other. Okay? And the very first lesson that you guys have to do is just kind of exploring that. And maybe even using that program might not be a bad idea for exploring what that function is. To draw a relationship for it, let's keep that on. Do we recall this function? What is it? A parabola. What is the inverse of this function? We write the root. Where's my root? X. Okay. And here it's not going to, because to keep it a function, it needs to have the vertical line test passed, so on this program it only draws that side of it. But this is essentially the inverse, and I could write it actually as x equals y to the power of 2, right? And that would be the inverse of our function. That's the same relationship with a logarithmic function and an exponential function, okay? So just like when a root was introduced to you, maybe in grade 11, in grade 10 you'd work with parabolas, it's a new function, you're just going to be looking at it. That's what a logarithmic function is to an exponential. It's just the inverse, okay? So just keep that in mind. It's not very different, it's just the inverse. So anytime we have to think of a value of it, we can always refer back to our inverse, and usually that'll help us clarify what we're looking at.